You can use velocity time graphs to calculate acceleration, and the Williams FW33 can accelerate from 0 to 100 miles per hour in only 3.5 seconds. Before the car reaches the first corner behind me, it's traveling at over 300 kilometers per hour. Now, if those acceleration figures doesn't impress you, then the deceleration will impress you even more. Because when you put the brakes on, you decelerate from 300 kilometers per hour down to about 150. We're going to calculate the acceleration and deceleration of different parts of my Formula One lap.
This is the actual velocity time graph of my Formula One lap when I turned onto the fastest part of the track, the start-finish straight. Let's take a look at the onboard camera. Now we can see from the video and from the graph that the car did not start from zero. The car was already moving when we started to draw this graph. So we can see here that the car's velocity was 15 meters per second at the start. And then we can see that the velocity of the car increases as we go along this section of the graph. Now, any time that the velocity of an object increases, we call it acceleration. So along this section of the graph, we would say that the car is accelerating. Now, in this section of the graph, the velocity of the car is also increasing. So we can say that the car is also accelerating along this section of the graph. And when the car gets to this point here, we can see that the velocity of the car was 85 meters per second. Now, 85 meters per second is about 190 miles per hour. And when the car got to this speed, 85 meters per second, we can see that after this, the car continued at 85 meters per second. The velocity didn't increase and the velocity didn't decrease. So along this section of the graph, we wouldn't be able to say that the car was accelerating. We would only be able to say that the car is travelling at a constant velocity or a constant speed. Now in this question, we're asked to calculate the acceleration of the car from A to B and from B to C. Now there are two ways to calculate the acceleration from a velocity time graph. The first method is by using the formula for acceleration. And the formula says that the acceleration equals the change in velocity divided by the time taken. And the second method to calculate acceleration from a velocity time graph is to calculate the gradient of the line. Because on a velocity time graph, the gradient of the line is equal to the acceleration. So you need to remember that the gradient of a velocity time graph is equal to the acceleration. Now actually we're going to learn that both of these methods are exactly the same as each other. Now we're going to start by using the acceleration formula to calculate the acceleration of the car from A to B. So we're going to need to work out the change in velocity of the car from A to B and the time taken for the car to get from A to B. And to do that, we're going to have to read off some values from the graph. Now we can see from the graph at A, the time was 0 and the velocity was 15 meters per second. And at B, the time was 4 and the velocity was 50 meters per second. But remember, any time that we're reading off values from a graph, we must draw a dotted line on the graph using a pen and a ruler. So at B, I draw a dotted line vertically down to the x-axis, where I can see that the time is 4 seconds, and then I draw a dotted line horizontally across to the y-axis, where I can see that the velocity is 50 meters per second. So to calculate the acceleration, first of all we need to work out the change in velocity. Now at A, the velocity was 15 meters per second, and at B, the velocity was 50 meters per second. So the change in velocity is the difference between these two numbers. So the change in velocity is 35 meters per second, and we need to divide that by the time taken for the change. Now at A, the time was 0, and at B, the time was 4 seconds. So that means that the time taken for the car to go from A to B was 4 seconds. So the acceleration is 35 divided by 4, which is 8.75. Now we need to put down the units of acceleration, and acceleration is measured in meters per second squared. Meters per second squared. This is now my final answer for the acceleration of the car from A to B.